This is video 24.2. We'll be looking at the refraction of light rays by a prism. The question: a light ray enters a prism at an angle of 50 degrees with respect to the normal. Assume the index of refraction of the glass is 1.52. We'd like to know what angle does the ray make with the second normal when it exits the other side of the prism. First, we'll find angle 1. To do this, we'll use Snell's law, which states that the index that's incident and the sine of the incident angle are equal to the same for the refracted angle. Now we'll plug in what we know. The incident index of refraction is 1 because the light is through air. The incident angle is 50 degrees, and the refracted index of refraction is 1.52. So we can rearrange to find theta 1. From this point, we have to take the arc sine, or the anti-sine of both sides. Using our calculator gives 30 degrees with respect to that first normal, as shown in the diagram below. Now we need to find angle 2, as shown in the diagram. Now this requires a little bit of geometric insight. First, I'd like to find the angle that second pink light ray, which is inside of the prism, makes with respect to the horizontal. Now follow along with me. The left leg of the prism is at 60 degrees with respect to the horizontal because it's an equilateral triangle. And then the normal, which is the dotted line on the left, is normal to that side. So it's 90 degrees with respect to that side. So it's 90 degrees down. So it's minus 90 degrees. And then the second pink light ray is 30 degrees above that left dotted line. So altogether, we see that the part of the light ray which is inside of the prism is exactly horizontal. This means that the image is symmetric about that red dotted line which has been drawn into the diagram. It's completely symmetric because it's an equilateral triangle and because the light ray inside of the prism is horizontal. This implies that theta 2 is equal to theta 1, which is just 30 degrees. Now we'll find angle 3. For this, we'll use Snell's law. This time the light is coming from the glass, so the incident angle of refraction is 1.52. From this point, we take the arc sine of both sides and we get 50 degrees. We could have argued this right from the beginning because we said that it was symmetric about the red dotted line. But I wanted to go through the computation with you just to see that it actually works out correctly. And that concludes video 24.2. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.